So hello everybody, welcome to our BIM masterclass session. Today we are going to talk about the unique implementation of BIM in an iconic project in United Arab Emirates, specifically Abu Dhabi. This is the Midfield terminal building project. Due to the extensive experience we had in this project and to the unique experience we had, this seminar or this masterclass will be over 5 sessions or more. It depends how much I want to share with you and we want to give you the flavor of our implementation and experience. To start with, just to give you an idea when we started the BIM journey, we started the BIM journey in 1997. So this gives us 20 years of age, experience, background, reputation, and skills. Our first success story was in the Ritz-Carlton Hotel in Doha, and this project is known to be the first BIM-based estimation project. Since that time, CCC realized the importance of having skilled and competent engineers who can run the BIM process effectively and efficiently. And as such, currently we have 225 BIM engineers. They reside in 3 different centers, one in Athens, one in Cairo, and one in Palestine. Besides, we have in each and every project a group of professional BIM engineers who runs the BIM services to the clients and to our project team on site. Of course, we have, CC has a centralized corporate BIM organization. In that BIM organization, we have the BIM centers, the 3 ones we described, the one in Athens, the one in Palestine, and the one in Egypt. We have a lot of projects running, and all of them under the same organization. We have partners such as Zigurat and Since1. We offer consultation to our clients beside our consultation services to CCC. We have a BIM Academy. We'll talk about it in a few minutes. And then we have partners who delivers BIM-based solutions, software solutions, which is CCT, which is a software house, and RASO, which is our implementation, our arm for system implementation. Now going directly to the project after this brief introduction, which is the Midfield terminal building in Abu Dhabi. In the beginning, I would like to give you a brief about this project, about the components, the contents, and I want you to realize the complexity, the difficulty, and the challenges in this project. Okay, so this project is an X-shaped building with 4 piers that connects people through gatehouses to the world. So this is the places where people get out and on planes. There is a central processes area where people do their shopping, their travel logistics, and their preparation for travel. The following slide has a lot of rendered images that demonstrate the complexity, the architectural features of this project. As you can see, each and every rendered image represents a feature that is unique, complex, and challenging. And as you could see, most of the features are curved, most of the features are complex in design and in geometry, which makes it difficult for a contractor, for a designer, for any stakeholder to deal with the development of that construction process. In figures, the following figures will illustrate to the audience the size and complexity of the project. So the Midfield terminal building, as you can see, resides here in the middle. It is between 2 other big contracts. One is called MTL, one is called MTA. The size of the project is about 700,000 meters square. The project value at tender was $3 billion. The aircraft capacity at the same time is about 65 aircraft connected to the airport at the same time. There are 106 gates. the number of passengers that can be served in 1 hour is about 8,500 passengers. Excuse me. We have 165 check-in counters. This was during the tender stage, but the number has increased now. The package handling system capacity is about 19,000 packages per hour. This is a huge number for those who work in the BIM in the airport business. The package handling system conveyor belt length is about 22 kilometers. And you can imagine how big is that airport that can accommodate 22 kilometers of package handling system conveyor belt. Actually, these figures are what we had during tender stage. Currently, the design has been changed. The capacity of the airport has increased. And for example, the package handling system length is about 27 kilometers of length. The following slide illustrates more figures, numbers, for those who are in the construction business. For example, the amount of concrete in that project is about 870,000 meter cube of concrete between precast and cast in situ. The total number of steel at the tender stage was 45,000 tons, but now it is about 66,000 tons of steel structure. This beautiful cladding for the roof has a built-up area of 260,000 meter square built-up area. Now, what adds more to the challenges of that project, that the client, which is ADAC, was very smart in seeking ways how he could make sure that the subcontractor and the contractor and the different stakeholders can use technology, can use innovation, can use new methods to deliver this project effectively. And as such, the client was brave to mandate and force all the stakeholders to use BIM to deliver the construction. And this contractual obligation ran from engineering phase, and he asked for a clash detection and design coordination process from within a BIM environment. He asked to develop RFIs based on the design coordination process that's happening in the clash detection process. Extract shop drawings from the BIM system. Have realistic rendered views to represent and realize the building. Second, he asked the contractor, the main contractor, which was a joint venture of 3 companies. CCC was one of them and was leading in the BIM function. He asked project controls and planning to be based on the BIM platform, and as such, he asked for cost estimation to be based on BIM. He asked to do 4D studies, construction animation studies from BIM. He wanted us to show the utilization of resources, labor, machinery, and manpower on site from within a BIM environment. He wanted us to demonstrate how we could collect progress, measure progress, and report progress of the construction process. And of course, if there is any scenarios, variation orders, or value engineering studies, he wanted us to demonstrate them from within the BIM environment. Also, he insisted to have all the variations, the quantity surveying process, done from the same environment. He wanted a scientific way to validate and verify changes. Definitely, he knew the importance of taking BIM until the downstream process, until the manufacturing process. And he asked us to leverage BIM for fabrication. And then at the handing over stage, which is very critical to the client, he wanted an as-built model. He wanted an integration with his facility management system and asset management database, plus operation and maintenance integration.